Hello. So yesterday we talked about a function. Is something a function or not? Is a relation a function or not a function? So we're going to kind of expand upon the idea of functions, and one of the things that we focus in on when we're looking at a function is its domain and range. So we're still in lesson 1.7, and we're going to talk about domain and range. So I've got kind of a cutesy little mnemonic device that deals with the idea of domain and range. So what we have is, across the top, we're going to talk about Dixie. And then over off to the side, we're going to talk about Royd. And domain and range deal with these features, okay? So D stands for domain. And we referred to that when we were talking about relations having domains and ranges. I stands for it's the set of all inputs. The X stands for it's the set of all X coordinates. Okay, so if you think back to that relations video, coordinates, not coordination, coordinates. How about if I fix that? There we go, that's better. And I stands for it's the independent variable. So across our 3 slides, we talked about relations 3 ways, and this is just putting it all in a nutshell. So for D as domain, it's the set of all inputs, the set of all X coordinates, and it is the independent variable. All right, so let's talk about Royd. Well, if D stands for domain, then R stands for range. Okay, and we do have different kind of range in math as well. Range can be the difference between your highest and lowest, but this is different. This is just talking about a set of numbers. So the O stands for the set of all outputs. Make that capital. Y stands for the set of all Y coordinates. And the D stands for it's a dependent variable. Okay. So we're going to be, again, recognizing if we have a domain or range, and we may be given information different ways. We're going to look at an example in our center here. And I'm going to give you a set of numbers, a relation. So it contains the ordered pair 0, 1, the ordered pair -2, 3, the ordered pair 5, 4, and the ordered pair 1, 8. Okay, so would it be a function or would it be not a function? Well, remember what we talked about is that each X value has its own unique Y value. And if you're noticing, we have a 0 pairs up with a 1, a -2 pairs up with a 3, a 5 pairs up with a 4, and a 1 pairs up with an 8. So let's break it down to domain and range. So the domain is going to be the set of all the X coordinates, and the range is going to be the set of all Y coordinates. Now in this particular example, we don't see a repeat of anything. So again, a function, each domain has a unique range. And again, I think this is a little bit easier to see if we go from the viewpoint of kind of like a mapping. So we could call this the input. And I'm just going to put some numbers in there. -3, -2. And then we have an output. And we'll just put in -1, 0, 4. And then we're going to draw an arrow to connect the input to its output. So -3 pairs up with -1. But -3 also pairs up with 0. -2 pairs up with 4. So because of the situation with the -3 pairing with -1 and -3 pairing with 0, that domain doesn't have a unique range. It has two different ranges. So this one is not a function. So that's a real easy way to tell if you have a function or not, is just map out your x-coordinates and y-coordinates and see if you have two arrows, two connections coming from one input. So going back to our guy, we would have to say he is a function. Okay. Now I'm going to go to my next screen, and you are going to have to copy these down, or you could print out the page if you wanted to, and we're going to determine the domain and range, and I'm going to kind of tell you how to do that in a simple fashion. So I've got 4 different graphs, and we're going to count each of the grid marks for the graph paper as counting by ones, and we're going to come up with what the domain and range would be. Now I'm going to give you it in a certain format, okay? It's called set builder notation. So we're going to learn what that looks like. Okay, so these are all kind of unique. So if I want to figure out what my domain is, I'm going to, you could use 2 pieces of index card to help you with this, or you could use like a piece of paper, cut out an X and fold up around the sides. You could simply draw on your pictures some vertical and horizontal lines to help you with that. So I'm just going to use purple to be my x-intercepts. So what I do is just basically draw lines where we see the edges from left to right. Now, what I notice is, let's see, on the left we're at 1, 2, 3, 4, -5. Now, it's a dot that's at the far left. So that's going to be an or equal to situation. Now we're going to put x in the center, and it's going to be less than or equal to. And then notice what you have there. So it can't be or equal to because it's going on forever because of the arrow cap. So then we're going to write here less than infinity. Okay, now we're going to do it this way. So this is the set of the domain values such that -5 is less than or equal to x is less than infinity. Okay, so that's the set. Or actually, let me write it a different way. Domain is the set of all values from -5 is less than or equal to x is less than infinity. So that graph is going to continue in an infinite direction. So that's going to be your domain. Let's talk about your range. So the range is the highest point to the lowest point. So I'm going to say actually from the highest point, it is and here's what's interesting. There's a definite beginning of how low it is, and we always want to start with the lowest number. So let's see, this would count down 1, 2, 3, 4, 5. So this would be at -5 is less than or equal to, now we're going to switch it to y, because now we're going to talk about the range. Okay, and then it's going to be, and then we had a line. So line means all those points are part of the answer. So it's going to be less than or equal to, and I'm going to say it was about -1/2. It's kind of hard to tell because it was super, super small. Okay, so drawing those lines at the far left and the far right, at the bottom part of the graph to the top part of the graph, is how I determine my domain and then my range. Now, what's interesting about the next one, this is a very unique one, that's why I included it in here, is that it doesn't have I don't have to use those inequalities, because those inequalities are saying it's every itty-bitty teeny little variation of a number from -5 all the way to positive infinity. Okay, so I don't have that here. I've got some distinct points. Remember we talked about a discrete data versus a continuous? Well, the first graph was continuous. This one is discrete. So what I'm going to do is look at those ordered pairs, and I'm going to pull out all the x coordinates. So the first one I see is at -3 on the x-axis, and then -2, and then -1. And then it looks like it skips, and it's at 1, and then 2, and then 3. Because it's individual distinct points, I list them separately. Now let's look at the y value. For every single one of them, the range is -2, and that's it. Okay. All right. Let's look at this guy. So we're going to go far left to far right. That's going to be my domain. Now, what I see is an arrow cap. So guess what? This is going to continue forever and ever and ever in the negative direction. So it doesn't start at -5, right? Because it's an arrow cap. So that's going to be negative infinity is less than or equal to x. And, can't be or equal to. I keep doing that. I'm such a bad girl. There we go. Because we can't ever equal infinity because it continues forever. So then we have negative infinity is less than x is less than positive infinity. Now, basically what I'm saying is that your domain values can be any number that exists. So there is a shortcut of writing this answer. And that is the cursive R, which means all real numbers. Okay. Now let's look at the y. How tall does it go? Hello. Okay. Now again, what butts up to those lines I just drew from what I saw in the graph are arrow caps. So that means I'm as low as negative infinity is less than y is less than positive infinity. So for the range, the answer is also all real numbers. Okay, now I picked these graphs in particular because they were hard. The ones that I'm going to have you guys do to practice on are far easier than this. All right, I've got one more practice to do. So I'm going to go far left and far right. Now, I'm just going to kind of, again, this graph is not perfect, so I'm just going to go to the nearest whole number just for the reason I want to. So on the left, I'm go over 1, 2, 3, 4, 5 boxes. So I'm starting at -5. Now I get to use a less than or equal to, because guess what? There is a point exactly at -5. That's as far as it goes, to the left. Okay? So then x goes in the center, and over here it goes over to 1, 2, +3. And because it's a point, it exists. It is an actual solution, so that's where the or equal to comes from. All right, let's try my range. So I'm going to go to the top and to the bottom. So my range, start with a lower number. Let's see, we're at -1, 2. I'm just going to call it -2.5. And that's going to be less than or equal to y is less than or equal to, and then we go to the top and we go up 1, 2, 3, 4. I'm going to say 4.5. +4.5. And so that's what you guys are going to do when you're trying to figure out domain and range of a graph. So you're going to look for arrow caps mean infinity. If it's arrow caps on both sides, then it's all real numbers. Like in the third example. If you have a definite starting point but an indefinite ending point, then you're going to have less than or equal to your starting point. If it's on the left side, which it could be, or the other side. And then if the infinite part is going to be infinity, but you can't say or equal to with infinity. Okay? So, this is going to be something kind of fun to play with. All right. Good luck with this, guys. Talk to you later. Bye.